You're welcome to Explore Insight. In this last practice, I'd like to treat on View Network Device MAC addresses. So to start with, let's take a look at the topology where we have one switch and one PC called S1 and PCA respectively. And you can see here, the cable we have here is the copper straight through cable. Next to it is the addressing table, which tells us about the IP address, the interfaces, the subnet mask, and the default gateway. Now we have majorly two objectives. One is to configure the devices and verify the connectivity. And next, we need to display and describe and analyze the Ethernet MAC addresses. Now, going through the background and the scenario, Going through the background of the scenario, you can have a look on what we have here. So every device on an Ethernet lab is identified by a layer 2 MAC addresses and all that. So I don't want to bug you up with so many information here. You can quickly take a glance at that. Now let's move over to the required resources. In this, we just need one switch, one PC, the console cable, and the Ethernet cable. Now, we'll follow through the instructions step by step. So looking at part 1, we have to configure the device and verify connectivity. So in this part, we'll set up the network topology and configure basic routers such as the interface IP addresses and device name. So for device name and address information, refer to the topology and the addressing table. So let's just start with what we have here. So in this case, what can you see? You notice that we have this, the S1 and PCA. So let's do that on our packet tracer. So we need a switch. So you come over here to take the switch. So we have the switch here. And then for the PC, you come over here, which is the end device. You click here, you take the PC here and put here. Now for the connection, if you look here, you see connections. Okay, so you click on this connection and then go to get your straight cable. Okay, so just take a look at what fast Ethernet are we supposed to use. So it tells us 0/6. Now, while we click on the switch, we're going to take 0/6, which is seen above. Yeah. And when we get to the PC, we're going to click on fast Ethernet 0. One more thing it says is we will need console. So let's do that straight away. So you click on console, and from the console, you click here and you click on console. And when you get to your PC, you click on ROS 232. So this is what we have here. So we are done with the topology. So the next thing we need to do is to fix in the device name, as you can see here, the IP address, the subnet mask, and the default gateway. So just here, let's change what we have here to S1. And also here we have PCA. Now on PCA, we want to give the IP address. So you come to desktop. Now in desktop, you go to IP configuration. Now, what is the IP address? Now you could see the IP address here. Yeah. And the subnet mask here and the default gateway here. So we are going to put this information right here. So in this case, we have 192.168.1.3. Now the subnet mask, you don't need to put it. It does that automatically. Then for the default gateway, which is this, we have to put it. So in this case, we have 192.168.1.1. So we've performed that as seen here. Okay. So the next thing we need to do is, let's see the step 1. Attach the device shown in the topology and cable as necessary. Done. Then power on all the devices in the cable. Now to power on, so let's see what we have for that. Okay, so you can see whenever it shows the green light, it tells you that it's on. Better still, you can also come here to check the power if you wish to do so. So you just check it to know if it is on or off, okay? Just check it. So when you don't see the green light, it shows that it is switch off. So you click it to switch it on. So you can see the green light. Let me zoom that for you. So you could see the green lights, okay? So that's it. Step 2 says we should configure the IP version 4. So I'm reading from step 2A. So here in step 2, we have to configure the IP address. So looking at A, we have to configure the IP address, subnet mask, default gateway. We've done that. Now the next thing we need to do is from the command prompt on PCA, ping the switch address. So we are pinging from PCA. So follow me as I implement that. So first of all, it's important for you to know what is the switch IP address. So the switch IP address is 192.168.1.2. So we are going to ping that from PCA. So you come to the desktop and come to the command prompt, and then you ping. Here we have ping 192.168.1.2. So when we ping it, you wait for the information that shows the packets sent, receive, or if there is any loss. Now let's see what we will get. So the first time we are seeing request timeout. And this third time we are getting request timeout. And then it's telling us that we sent 4, received 0, lost 4. So it means that was not successful. So let's go back to see the question we have attached to that. So it says, were the ping successful? No. So why was the ping not successful? This is because, if you recall, we only put the IP address for the PCA. We didn't do that for the switch. So it means that the switch has not been configured yet. So having known that, let's go to step 3. So looking at step 3, you could see that at this point, we need to configure the basic settings for the switch. And how do we do that? We have to go to console into the switch and enter the global configuration mode as seen on step 3A. Okay, so we are going to do the following. So we are going to configure the device name, the IP address. We'll disable the DNS lookup on the switch. So follow me, let's do that. So for the switch, I'm coming over here. I'll click on CI, click my enter key. Now in this mode, we are having it as the user exec mode. So I just need to type EN. From here, EN also means enable, so that's just the short form of enable, which will take us to the privilege mode. And once we are there, we're trying to follow these lab exercise instructions to do the following given tasks. The next thing is we need to move to the configuration mode. So we need to type config T or configure terminal. So the shortcut is just config T. So follow me to type that, config T. And after our config T, we are asked to give the host name, the name. So we are changing the switch, which is the default name, to S1 as the name we want to give it, not using the default name. And you can see that it will change from switch to S1. And the next thing we need to do is say we need to disable the DNS lookup. So the DNS, which is the domain name system. So we have to do that by typing no IP domain lookup. I guess my spelling was wrong, so permit me. I missed one O in the lookup. So done. Now the next thing we need to do is this time we want to configure the switch S1. So how do we do that? We need to get to the interface configuration mode. So we say interface VLAN 1. And then we try to get the IP address. So if you look there, our IP address is 192.168.1.2. So let's key that in. IP address 192.168.1.2, and then you put the subnet mask, which is 255.255.255.0. Then you write no shutdown. So having done that, the next thing we need to do is to look at the next task. And in the next task, it moves us to step 4, which is to verify the network connectivity. Now remember that we've done something like this before. It means that we are asked now to ping the switch again from PCA. Now let's ping again. Okay, so there's a shortcut here. You don't need to type it again. Just use your forward arrow key and click on it. It will bring the previous information you've typed before. So once I do that, let's see the difference. Remember, at this point, we had 4 timeouts. Sometimes you can even have 3, but the most important thing that tells you if the packets were sent or not is within this region, okay? So at this point, you can see the difference that at this point, we sent 4 packets, we received 3, we lost 1, which is just 25% loss compared to the 100% loss we had initially. So this shows we have a successful ping. Okay, so let's go back to the question, was the ping successful? Yes, the ping is successful. Now, moving on to what we have here, this is just details telling us about the MAC address. Now recall, MAC address has 48 bits long, and for that address is split into 2 and is represented with different names. Some devices call it the physical address, some the hardware address, some the Ethernet hardware address. So any of this name still go with the name representing the MAC address. Okay, so just in case you don't see MAC address, remember the other 3 names I called. Now also, if you take a look at this, we have 3 different notation methods for MAC address. It could go with a dash, it could go with column, it will go with period, okay? So these are the ways, and you can also see the different names the MAC address are called, like I have said before. Okay, so in step 5, we want to analyze the MAC address for PCA NIC, okay? Network interface card. So what do? So you can issue the ipconfig space \all command to view the MAC address of your NIC. So we'll use this command to do that. But before you proceed, let's take a look at what we are supposed to know about this MAC address. Now, for the MAC address, you can see that it represents this part. So let me do that for you. So let me just take this one for instance. I told you, like I said, any of them is still the same representation of MAC address. It just have different notation. Now, if you count this, you see that it is 12. So the first 6 hexadecimal, that means this. The first 6 hexadecimal represents the OUI. OUI means the organizationally unique identifier, whereas the last 6 digits are the NIC serial number assigned by the manufacturer. So just in case you want to know the manufacturer for your device, you can use this first 6 to know that. And one extra information is this OUI is being assigned to the vendor by IEEE organization. Okay, so let's do what we're supposed to do. So we are going to type ipconfig space \all first on our device. Then we go ahead to do it for PCA and PCB. And then try another method for the switch. So let's get right in. Okay, for us to check what is the OUI portion of the MAC address for this device, you just type ipconfig space \all. And this is what I have here. So the first 6 is my OUI, and the last 6 is my serial number. So I've put my information here. So using the example above, check the name of the vendor that manufactured this NIC. Okay, so you can do that, not necessarily using my own information. So use your own device to know what you have and fix the answer here. You can actually use this website to check it. Now, the next thing we want to see is we want to check the MAC address from PCA, okay, so that we can be able to tell the OUI and tell the serial number and what manufacturer has that information. So if we do for PCA, the same thing, we are going to have this information for PCA. So if you look here, this is the MAC address. So we'll have the first 6, 00400B to be the OUI and the serial number 3EB9D9. That is what I've written here. Okay, so for the manufacturer, we all know that it's going to be Cisco system because this is Cisco. So it's Cisco system. So I don't know which manufacturer device you're using, but for the PCA, it's Cisco system. Now let's go to step 6. In step 6, we need to analyze the MAC address for S1 F0/6. So for us to check for the MAC address for S1, we need to use the show interfaces VLAN 1. So we have to go to S1. So while we type our enter key, we use EN to get to the privilege mode. So we say show interfaces VLAN 1. Now when you do that, you're going to see the MAC address here. So let's go to the next thing. Just like the screenshot you have here, that's the same information you can see here. Now the question is, the MAC address for VLAN on S1 is what? If you want to answer that question, it means we have 0001.42AE.252E. Out of this MAC address we have, what is the serial number? So the serial number will be the last 6, which you can see here, and the OUI will be the first 6 ESA digits. Okay, so we've done that. Now, based on this OUI, what is the name of the vendor? Cisco system. So what does BR stand for? That is burn-in address. So let's move on. Now, why does the output show the same MAC address twice? What does that mean? If you look here, we have the MAC address twice. So why is it so? Well, the MAC address can be changed via a software command. So this actual address, which is the BR, will still be there and it is shown in parentheses, as we can see here. Now, another way to display MAC address on the switch is to use the show ARP command. So let's show the ARP command to display the MAC address. So other than using the one we used here, which is the show interfaces VLAN 1, we can use ARP space -A. Okay, so let's see that. So we'll come to S1 and say show ARP, and you can see it's even easier and more clearer here. So the same information you have here. So we can see some questions here. It says, what layer 2 addresses are displayed on S1? So we have S1 VLAN 1 and PCA MAC addresses. Remember, the MAC addresses works in the layer 2, which is the data link layer of the OSI model. The next question we have is, what layer 3 addresses are displayed on S1? When we talk about layer 3 addresses, we're talking about the network layer on the OSI model. So what can we see there? It means that we can see the S1 and PCA IP addresses. Okay, so we've answered this. Now let's move to the next one. We want to view the MAC addresses on the switch. So if we want to view that, we need to say show MAC address table. So let's replicate that on our code. Show MAC address table. So we have that. So at this point, I just want to emphasize on something in case if you experience that. So when you click on your S1 and you say show MAC address for this step 7, you might not get an information. So don't panic about it compared to what you can see here. All you can do is to take the important one, which step is to go back to ping. So if you ping from your PCA, you ping S1. So just repeat the address. Once it goes successfully, come back to S1 and recheck your show MAC address table, which will update what you just did. And then you're going to see this information, just one of it. Okay. So let's go to the next one. Does the switch display the MAC address of PCA? Yes. So if your answer is yes, what port was it? The port is FA0/6. So which you can see here, FA0/6, which you can see here. Now let's go to the reflection question. Now, can you have broadcasts at layer 2 level? If so, what could the MAC address be? So yes, we can have broadcasts at layer 2. AROP will broadcast to find MAC address information. So the broadcast will be this FFF.FFF.FFF.FFF.FFF.FFF. Okay, so recall that this F represents 4 bits, 8421, which is 1111 for each F. Now, why would you need to know the MAC address of a device? So there could be a variety of reasons. So in a large network, it may be easier to pinpoint location and identity of a device by its MAC address instead of its IP address, since IP address changes as you take different destination or geographical location. So the MAC OUI will list the manufacturer, which will help narrow down the search. Then the security measure can be applied at layer 2. So knowledge of allowable MAC addresses will be needed. Okay, so thank you for staying up to this time. I hope you enjoy the content with me where we talked about 7.2.7 lab, where we have a view network device MAC addresses. So thank you for watching. Do not forget to like, to share, and also to subscribe, and also hit the notification bell so that you get updated on my subsequent videos in this channel. Have a nice time. Enjoy. I'm signing off now. Bye.